Hi, I'm Jin Chuan from the Typical Data Science team. Learning patterns of user behaviors with machine learning from the time series data empowers us to identify interesting groups and better serve our customer needs. In this demo video, we will show how we get to know different groups of users with different behaviors on the energy consumption data. In the first part, you will see those insightful results presented with the interactive typical Spotify dashboard. Then you will learn how we obtained those insights with advanced analytics in typical data science platform. Last but not least, my teammate Eric will explain how to connect these two powerful analytics tools together with big data function. The methods used in this video can be applied in many other business use cases to identify common patterns or anomalies in time series data. For example, analyzing mobile data usage, air quality records, real-time outputs from IoT sensors, website activity, and so on. So let's start from now.
We have created 4 tabs in this Spotify dashboard to showcase our findings. From the first Data Summary tab, we can understand that our dataset contains hourly electricity consumption records for 7 days, and it's actually from Monday to Sunday, for 228 unique devices with applying this filter. The distribution over the device installation data is also displayed as a bar chart over here, and the pie chart shows the number of devices for each type. Notice that we are using first-order difference data time series in the following analysis, which means for each timestamp, the value is replaced by the difference between the value and the value of the previous timestamp. This is useful for converting a non-stationary time series to a stationary form. So in the heat map on the right side, each row shows the consumption for each unique device. Then blue color represents an increasing trend of electricity usage, and orange color represents a decreasing trend, which allows us to observe several seasonality patterns as well. Moving on to the time series summary table, we can select device ID from the list over here and inspect a single time series. Then we can see the results of 4 types of analysis. The line chart over here shows the first order difference time series over the entire timeline, and we can use the built-in forecast function in Spotify to track some predictive future values. From the top left chart, we can tell the values follow a normal distribution, and on the bottom left area, we plot out some values from autocorrelation function and partial autocorrelation function in order to explore the relationship between different time lags. Time series decomposition results show us the clear patterns of trend, seasonality, and remainder. Next, on this exploratory data analytics tab, we start to apply clustering analysis on our data. We can apply the hierarchical clustering among all devices, which is a simple non-parametric method to track if some devices are highly correlated to each other. But this is hard for us to decide how many clusters we actually want to obtain. So it's probably better to use k-means clustering. On the right-hand side, we have this evaluator that can take in parameters of minimum and maximum value of k and return the plot of down index and weighted sum of squares arrows over different numbers of clusters. From the weighted sum of squares arrows chart, we can observe the elbow when the number of clusters is 5. Meanwhile, down index gives us a reasonably high value, which is a good indicator as well. So in the final tab, we apply the k-means clustering with 5 clusters. Then we are ready to further digest the clustering results. The most interesting part is the original consumption time series for each cluster. as in we want to learn if there is any natural behavior in each cluster. Since this is a very interactive dashboard, we can select each cluster from this count distribution bar chart, then observe the consumption pattern of each corresponding cluster. When we click on cluster 1, we can clearly see that it has a very consistent peak values in the morning and evening. Also, the overall usage is not very high. So this should be a household group. Then for cluster 2, it maintains a very high usage level from 8 a.m. to 9 p.m. on weekdays, but almost zero usage on weekends. We can guess this group can be offices that open on weekdays but close on weekends. For cluster 3, it shows a similar pattern with cluster 2, except that there is active usage on Saturday. So we guess these are some restaurants or shops that open from Monday to Saturday. For cluster 4, it is interesting to see that these users are only active for midnight time on Thursday, Friday, Saturday, and Sunday, so it looks like they are the night class. Lastly, when we check on cluster 0, they seem to be users with relatively low usage and even inactive users. We may treat this cluster as a special group that we can do further analysis in future. Now you may wonder where these cluster results come from. Let me introduce what we have done in typical data science. We have created these 3 workflows with typical data science for this project. In the first workflow, data manipulation, we start importing the electricity consumption raw dataset and join the table with device information table. Then we do some data cleaning, including the null value replacement, and filter by device type. This operator recode is actually removing all the records with negative values, which is regarded as invalid inputs. Then we start to calculate the usage by hour, and we apply the window function to calculate the lag. For the next part, we need to calculate the first order difference time series data by taking the difference of the current timestamp and its previous timestamp. Then we also calculate the mean and standard deviation for the normalization purpose. Lastly, we apply the pivot operator to convert all the hours as the column. In the second workflow, exploratory data analysis, we import the pivot result that was generated from the previous workflow. Then we can apply the k-means cluster evaluator to track the values of down-index and weighted sum of squared error. We can also see the result from here that the number of 5 clusters is a good choice. Then we apply the transpose and calculate the correlation between those time series data. The last workflow is where we apply the k-means clustering. We simply need to connect our pivot result with this k-means operator by selecting the columns that we want to use for the clustering analysis and define the number of clusters and maximum optimization steps. Actually, these 2 values come from the Spotfire dashboard given by the user. In typical data science, we provide a series of out-of-the-box modeling operators for you to simply apply the machine learning algorithm with drag and drop. We also have other categories of operators that can help us to build an end-to-end visual analytics workflow. Next, I will let Eric to introduce how to make typical data science and Spotfire work well together.
In Spotfire, we can create a TeamStudio data function, which allows the users to execute the TeamStudio workflow and brings back the data in TeamStudio to Spotfire. After inserting the TeamStudio instance information and credential, we can select the workspace and the workflows of interest from the dropdown. Next, we will need to configure the input parameters for the data function. In this case, we select the number of clusters k and the maximum iteration for k-means as the input parameter. After that, we will need to define the output, which is the data we want to export from TeamStudio to SpotFire. We can use the export to SPDF operator in TeamStudio to do so. This operator will store the upstream result as an SPDF file, and the file will then be picked up by the data function. We can also define the output to be the visual table result within the TeamStudio operator. By specifying the operator name and tab, then the data function will go ahead and download it to SpotFire. The last step is mapping the defined parameters to SpotFire in TeamStudio. In the SpotFire side, we will map the input parameter as the SpotFire document property. In TeamStudio, the parameters will be mapped to workflow variables, and these variables will be the dynamic input of TeamStudio operator. To make this data function and its parameter interactive, we can simply create a text field with icons and input box. Now, the SpotFire users can easily change the model parameters, send it to TeamStudio, and get back the result table.
We hope that you have learned how to apply clustering to time series data to identify different patterns of user behavior, and more generally learned how typical data science and SpotFire can work well together to help us obtain insights from machine learning models in a way that is interactive and easy to understand.